we are presenting you a departmental informative session on the various dual degree specializations. We are delighted to welcome our guest speakers, Professor Nilanj Das Chakradhar, Professor Mahendra Reddy, Professor Atul Jain, and Professor Jeevan Jyoti Chakrabarti. Now I would like to ask Professor Jeevan Jyoti Chakrabarti, the faculty in charge Mekanika, to please begin the event.
All right. Thank you, Kanha. A very good evening to all of you. So this is the first event of Mekanika, not the first event of Mekanika per se this year, but the first event of Mekanika in which uh, professors are involved. And I would just like to give a brief introduction about what has been happening in the background. So basically, after the pandemic started, Mekanika died. Okay, it was majorly my fault, but mostly it was also the pandemic's fault. And I did not want to pressurize any of the students who had better and bigger things to worry about. So now, over the past couple of months, through extreme help from some of the older office bearers of Mekanika, and in particular, Bhalchandra Patil, who is a fifth year student and is also the UG representative, we have managed to, I would like to say, revive Mekanika. And we now have a fresh set of office bearers. Kanha is one of them. We have a few others. And we are slowly trying to limp back to normalcy, as they say. So I hope with all of your concerted participation, we'll be able to not just revive it, but to make it better than earlier. Now, I won't speak more than these few sentences. Rather, I would first of all extend my immense gratitude to the three faculty members, Professor Nilanj Chakradhar, Professor Atul Jain, Professor Mahendra Reddy, for agreeing to help us out in this important session. And without any further ado, I would first of all request Professor Nilanj Das Chakradhar to kindly begin the actual contents of the discussion session through some information regarding the dual degree specialization of manufacturing science and engineering, which the students have to choose now that they're in their sixth semester. Okay, so the reason that, so many of you don't know this, the reason that I am inviting Professor Nilanj Das Chakradhar first is that we have this rather arbitrary nomenclature of assigning manufacturing science and engineering specialization as ME1, thermal science and engineering as ME2, and mechanical systems design as ME3. It is just a code that we have been using for whatever historical purposes in our department. Okay, so first is ME1 by Professor Nilanj Das Chakradhar. So Nilanjan, please.
Thank you. That was a very warm welcome, Jeevan. So very good evening to all of you. So before I start, I would request all the students to turn on their video. I want to see them. Is that possible? Can you see me?
Yes, sir, we can see you.
Yes, Nilanjan, you are visible.
Okay, okay. So what about other students, attendees? Yeah. I mean the dual degree students, can you turn on your videos? Yeah, good.
Kanha, I just want to interject a little bit. Is it perhaps possible to remove this background and put Professor Chakradhar on the actual?
Yes, sir, we can. Avanti is on it, sir.
Oh, there's a screen share, just the screen share, yeah.
Should I stop sharing my screen?
Yeah, you can stop share, yes. If you stop sharing, then probably I would see more students. Yes. Okay. Very good. So, as Jeevan has already introduced, I have been asked to give you a brief on the ME1 specialization, particularly for the dual degree students. Now, as you know, so our attitude is always to present something. So I have prepared like 2 slides, and hopefully that those 2 slides will help you to choose your dual degree project. Also, how you will be choosing the elective subjects that will also come from the research areas. What are the available research areas in the ME1 specialization? And whether you're interested or inclined to those research areas depends on how or what areas you want to look for your jobs, or what is your future endeavor, all those things. So yeah, I have seen a couple of faces already, so you can turn off your video now. I'll share something. Okay, and I've been given 15 minutes. I'll generously use 15 minutes only, maybe less than that. So can you see the screen?
Yes, sir.
Okay, very good. So in this particular screen, what you see is about 12 research areas that are available with ME1 specialization, that is manufacturing science and engineering specialization. And the reason I have put this as the first slide is you will get a quick glance of the entire specialization, different areas, different electives, and also you can orient or you can incline your interest accordingly. So what elective you would choose, or what research topic you would choose for your dual degree project, that also comes directly from here. Just a sec, sorry. Okay, so here we see at the top it begins with machining. Sorry, just a minute. So you see it begins with machining, then micro machining, surface engineering. So surface engineering takes care of all the tribological things between two surfaces. Say for example, coating, thermal spraying, and different techniques. Composite manufacturing, then your robotics, deep learning, and neural network if you're interested in the robotic designing a robot or robot arm. Then modeling and simulation, something which has been shown to be very helpful during the pandemic, because either you are not allowed to visit the department, or maybe you are at home. So this kind of saved us, not fully, but yeah, somewhat. Then CAD/CAM, intelligent systems and machines, laser processing, then additive manufacturing. So you may know that our department houses at least 4 to 5 additive manufacturing machines. Then non-traditional machining, metal forming, and friction stir welding. So these are broadly the research areas that are floated to the BTech students, to the MTech students, dual degrees, and as well as to the PhDs. But of course, it is not exhaustive. And the next most important slide, which the students prefer to know, is mapping with the areas, mapping of the corresponding research professors with the research areas. So mapping of the teachers with the research topics. So here I have given as much as I could. There are currently 14 professors in ME1 specialization, and each professors are working on one or more of the areas. Obviously, again, the list is not exhaustive, but I have kind of mapped the precise areas each individual faculties are working in ME1. So to begin with, Professor Sitpara working in micro machining, surface engineering, then non-traditional machining. Professor Roy Chaudhary working in additive manufacturing, non-traditional machining. I think this video is being recorded, right?
Yes, sir, we are recording it.
Okay, so that's good. Otherwise, you can just take a snapshot of this particular slide. Then Professor C.S. Kumar in the area of CAD/CAM, robotics, intelligent machines, additive manufacturing. Professor Pratihar in robotics, intelligent machines, deep learning and neural network. Then myself in composite manufacturing, process modeling, as well as wear modeling. Professor Parthapratim Bandyopadhyay, surface engineering, tribology of coatings, machining. Professor Partha Saha from Additive Manufacturing, Non-Traditional Machining, and Professor Poonam Sundrial, Flexible and Variable Electronics, Supercapacitor, Non-Traditional Machining, Professor Sankhadev in Micromachining, Machining Robotics, and Professor Tamang in Welding, Other Joining Processes, Professor Soumitropal, Machining, Micromachining, Surface Engineering, Professor Eskapal in Friction Stir Welding and Metal Forming, Professor Panda from Metal Forming and Metal Casting, and finally Professor Rachela, Friction Stir Welding and Numerical Modeling and Simulation. Now the reason I wanted to show you this, because firstly it is difficult to find in one, in one shot what different faculties are doing in different specialization. So this is only for the manufacturing specialization. And once you get this, you can orient whatever which particular field you want to work on, and you contact those professors or those teachers accordingly. You choose the electives or subjects you want to have. You want to have a credit in credit as ME1 dual degree. Okay, so that is from my part. Now I would like to take more questions from your end.
Actually, Nilanjan,
Yes.
if you don't mind, I was thinking of keeping the questions pending for later on.
Okay, fine, absolutely fine.
We can take the questions, I mean, as they come in a combined fashion.
So I'll stop the sharing. Did I stop or is it already stopped? No, I did not. Okay, yeah, fine. So questions at the end, then I'll mute my mic. Thank you.
Thank you, Professor Chakradhar. I mean, very, very systematic way, as is his usual style. So I hope a lot of the students will be motivated to take up ME1 dual degree specialization. I would also like to point out one very, very important point, which some of your seniors missed out on and later regretted. And that is that at least in Mechanical Engineering Department of IIT Kharagpur, the robotics thing is pursued by the manufacturing people. The subjects related to robotics are mostly there in the electives, the dual degree electives which you will have to take. Those are present in the robotics stream, in the robotics in the manufacturing science and engineering specialization, not in the mechanical systems design. So many people have a wrong notion, and they don't look up the information also properly, and they just anyway take it, and later all they want to do is robotics type of electives, but they can't take it, okay, because there are certain restrictions. Talking about the restrictions, I am interjecting before the other professors can speak, because I want you to keep this thing in mind, and for which there has been quite a bit of heartburn among the students because they did not realize it first of all. See, as far as the electives are concerned, okay, as far as the electives are concerned, not the dual degree electives, because you are all dual degree students here, I want you to make this clear-cut distinction. For the electives, you are allowed to take almost all the subjects which are at the 4th year level and beyond. With some exceptions, maybe some 3rd year subject may be allowed. From the department, as long as a subject is there in the department, manufacturing, mechanical, whatever, if it is there in the department, if it is running, then you can take it as an elective. Please also note that in ERP, eventually when the time of your subject registrations will come, many different subjects will be shown up. That is, for lack of a better word, just a bug in the ERP system and the way that they coordinate with the academic section. Please do not disturb Professor Atul Jain and Professor Mahendra Reddy, who are your faculty advisors, with things like, see, this is the Senate approved subject list in the ERP, you have to give me this. No. Alright, that is not the Senate approved thing, that is a mistake there in ERP. That happens every year, every semester. Okay, so it's a mistake from the ERP. There are certain subjects in the elective list which should be there. There are many subjects in the ERP list which are shown, but that is not actually there. Okay. However, beyond that list, if you so desire, maybe depending on the kind of BTP you take or some other interest, you are allowed to take some other subject which may not be displayed in the ERP list also, but some other department running in the department, within our department. However, for your dual degree specialization subjects, dual degree elective subjects, okay, separate from electives, you are allowed to take only and only the dual degree electives that are floated, meaning the PG, the postgraduate electives that are floated along with this, with the things which are so these are the subjects which are also taken by the actual gate cleared MTech students. All right, so you'll study those subjects with them, and that's how you distinguish yourself as a dual degree student. Again, there should not be any confusion about it. So these are the kinds of subjects where robotics related subjects will be present in ME1. So please make a special note of this. Similarly, the other subjects will be discussed and the other things will be discussed by, I think Professor Mahendra Reddy has already joined us. So I will next request Mahendra to please speak a few sentences giving us a good idea about the thermal science and engineering.
Yeah. So thanks a lot, Dr. Jeevan. So regarding thermal section, so as you know, the thermal section is like dynamic as well as very vast. Okay. So regarding field of interest or areas, many areas are like CFD. Okay. The CFD particularly about nowadays developing novel codes, okay, like conditional momentum closure, and even that is 1, 2, as well as application of different probability density functions for reacting flows. Okay. These all are nowadays very interesting, and once you publish very, or otherwise once you write a code kind of thing for these particular applications, then you can show your this particular code in case of your replacements also. Okay. So regarding the professors in this field, few professors are working in this field like Professor Sopnath Rai, Professor Subhanshu Rai, even Professor Manav Kumar Das, okay, like even Professor Lakkaraju, Rajaram Lakkaraju. Okay. So nowadays the CFD, what is the advantage of CFD means? This is reaching your solution more close to the experimental analysis without building so much of expensive experimental setups. Okay. So that is one good area. And nowadays more interesting and popular area is like microfluidics, because that is ensuring certain techniques about medical apparatus as well as the flow or blood circulation in human body, and also like hard working methodology or principle in terms of thermal and fluids application in the medical whatever the science. Okay. So in that case, actually microfluidics is one of the prominent area nowadays. So as you know very well, Professor Suman Chakravarti, okay, even Professor Aditya Bandyopadhyay and Professor Purvarandhar, okay, they are working in these fields. And another interesting area and also evergreen area is like multi-phase flow, because almost all the applications in thermal field as like your thermal power plants, okay, so even the nuclear power plants, okay, so many applications are working on these principles of multi-phase flow. Okay. So that is the reason even more novel techniques of both experimental methodologies as well as computational analysis is still required in this field. Okay, is all the time looking for novel techniques for this. Okay, that is one thrust area in this field of thermal science. You can select even Professor P.K. Das, okay, and even some other professors also who are involved in other areas like Professor Manav Kumar Das. Okay, they all are working in this field. Okay, and regarding combustion, so I am working in the area of combustion. So like nowadays the major challenge is like you have to all the time look for alternate fuels, carbon free fuel especially, because if it is the carbon free fuel, then you can avoid CO, carbon monoxide, as well as the carbon dioxides, which are causing for global warming. Okay, at the same time that fuel should be renewable fuel, as like ammonia as well as hydrogen. Okay, so for this particular thing, since these are the whatever the new fuel you will be finding out when you are doing simulation or experimentation, some chemical kinetic analysis is required. Okay, so these all are thrust areas in this field. and nowadays even the internal combustion engines. Okay, so that is the more challenging area now, because so we are in the total world is in the dilemma such a way that whether to go electric vehicle or should we continue internal combustion engine. Okay, if you shift to the electric vehicle, where is the source for your electricity? Okay, countries like India, you have to all the time depend upon your thermal power plants. It means running by coal. Okay, so in that case, again you are somewhere you are producing emissions. These electric vehicles you are running here, okay, in the city, and you are saying this is the clean way of lifestyle. Okay, so but that is not the solution. Okay, so in that case, even in we cannot shift directly to the electric vehicles. If we have renewable fuel sources, okay, or otherwise the clean energy sources, so then we have to depend upon internal combustion engines only. Then how about emissions? Okay, the challenging like how to use renewable fuels in the internal combustion engines like ammonia and hydrogen, okay, which are carbon-free fuel. Okay. Then engine modifications are required, even its burning characteristics we have to characterize. That is one challenging area nowadays. Okay, burning of even dimethyl ether. Okay, so there is no carbon bond over there. Okay, dimethyl ether is one of the alternative fuel along with ammonia and hydrogen. Okay, these are major challenges in case of internal combustion engines. Professor Dhananjay is effectively working on these fields. Okay, apart from that, very well-known field is everybody know about that, the heat transfer. Okay, so heat transfer nowadays, what you have to do, compactness of your heat exchangers. Okay, so that is one challenging area, and also the electronic equipments are nowadays increasing. Usage of electronic equipments, cooling is the major problem. Yes, so in that case, how effective your design is about ensuring the cooling system in your particular electronic devices. Okay, so for the cooling purpose, you cannot add much more again, many fans kind of things or anything. Okay, in that way, the system itself would be working. Okay, so that is one area. Professor Anandarup is working in that area very effectively, and also waste heat recovery. Okay, in thermal power plants or any other plants, whatever the process industry is, so much of waste energy is going in waste. Okay, so how to recover it? In that way only you can improve thermal efficiency of the system. These all are actually looks like very traditional studies. Okay, very traditional studies. Nowadays our view is going upon new studies like AI and all. Okay, but these kind of studies only ensuring your energy security to the nation or otherwise world. Okay. So these are the thrust areas like heat transfer and application of AI. Okay, once you apply artificial intelligence upon these all areas, okay, upon these all equipments, whatever so far I have mentioned, that way you can simplify the system and you can improve the efficiency. Okay, and manpower you can decrease and fault you can find out very easily. That means you have to implement your electronics knowledge as well as your computers knowledge, okay, your coding knowledge upon your all operating systems like thermal systems like power plants. Okay, so that is one thrust area. Okay, and even gas turbines. So Professor Guha is working in this area. Okay, so all the time gas turbines is challenging field. Why? Because you can replace engine of the car with your electric whatever the vehicle, but you cannot replace the aircraft engine. Okay, because there so much of energy density is required. Yes, that is nowadays means that is even nobody thinking to replace that. Okay, even if you want to replace, even that is for 2 passenger, 3 passengers, small aircrafts you can replace. Okay, but large commercial aircrafts, so nobody thinking even because that is not possible. Yeah, so that's what gas turbine combustion or gas turbines study. That is like blade cooling or improving the efficiency of the compressor systems. Okay, this is the evergreen topic. Okay, where Professor Guha is working. And even as you know very well about R&AC, refrigeration and air conditioning, there also system compactness as well as improving performance, okay, and with the reduced efficiency and many refrigerants are like actually not human friendly. Nowadays, new refrigerants are coming. Okay, and also how to implement these refrigeration systems effectively by following HVAC, heating ventilation. Okay, so this is one thrust area, as you know, Professor Ram Gopal and even Professor Saurabh are working in these fields. Okay. So these are different evergreen thrust areas of mechanical engineering, and even different professors are working in this field. Okay. So to take these all courses means in these areas, if you would like to work, respective courses are available like electives. Okay. So you can prefer those all electives. Okay, with your wise knowledge, first you have to select your topic, then you can choose your elective also. Okay. So even sometimes you can approach me if you have regarding thermal subjects, if you have any doubt, then if it is possible and if I have some free time, then I can suggest you. Yeah, so this is about thermal subjects as well as thermal faculty who are working in these areas. Yeah, Dr. Jivan.
Thank you, Professor Reddy, for such a detailed explanation. These are your kids, after all, so you already have a very nice comfort level with them.
Yeah.
I'm sure. Yeah. Uh, Next, we are going to invite Professor Atul Jain. He is going to speak on the mechanical systems design specialization. So, Atul, please.
Okay, thank you. Thank you for the opportunity. So, even though the name of the specialization is mechanical systems and design, but sometimes we also use the term applied mechanics and design. Okay, this new name or this alternate name, applied mechanics and design, becomes important because this makes, I think, does more justice to what the division is doing. So if you look broadly at what happens in the applied mechanics and design division, we have mechanics of materials. Mechanics of materials means any type of material, how it is going to behave when a certain load is applied. Broadly speaking, that is what you'd like to understand. And mechanics of materials, within our section, there are large number of materials that we study. For example, fiber reinforced composites, smart materials, materials where if you apply electrical signal, it gets some deformation and vice versa. Or you have specially tailored metamaterials like auxetic materials, materials with negative Poisson's ratio, really pushing the boundaries. Previously, when we were making new structures, our first starting point was what nature can provide. And starting from that, we will develop whatever structure we want to do. But now the philosophy is changing. The philosophy is not what nature has to provide, but what we want. And accordingly, we will design the materials. So, or in other words, the workshop is not the starting point, but abstract mathematics is the starting point. So in this field, there are number of people who are working on this field. Also from mechanics of materials point of view, the fracture behavior, etc. Then there is dynamics and control, acoustics, the sound, the vibrations on this field, tribology. There is lithium and ion batteries, human body mechanics, fault diagnosis. So it's a big basket of different aspects of design. Designing from the point of view that there should be less friction, or designing from the point of view that there should be less vibration, less noise. Or if a machine is already running and there are faults in it, how do you diagnose the faults? Or how do you do the instrumentation and control? All of that comes in the applied mechanics and design division. And another way of looking at what is being done is you can divide the work into, I would say, theoretical or numerical, or you could do experimental work. And we have extensive faculties and extensive facilities for both. And another important point I want to raise is that even though these three divisions are clearly demarcated, manufacturing, ME 1, 2, and 3, but the research is not so clearly demarcated. So For example, among the people who are here, I think if you look at composite materials, there is manufacturing of composites and there is mechanics of composites. And I think Nilanjan and myself deal with both. He might be more inclined towards manufacturing. I might be more inclined towards mechanics, but it does not mean that he doesn't touch mechanics at all. Or it does not mean that I don't do manufacturing at all. So there is, I mean, the boundaries between the different sections are a little bit gray. Yeah, and I think, yes, I want to say that much only. If any questions, then I'm happy to answer.
Thank you, Professor Jain. So I would like to add my 2 cents worth and maybe 1 minute worth of discussion on this mechanical system design, simply because I am myself a faculty from mechanical system design. So it has been very nicely summarized by Professor Jain on the elective side of things, because I have suffered through the entire discussion sessions with my faculty advisory batch, the current 5th year batch, 17 ME MF. I keep on harping on this particular thing because many of you may not be that much interested on the research aspect side of it, although you are supposed to be as dual degree students, but maybe more on the on what kind of subjects that you have to study. So on that note, I would like to point out that there is some sort of a misconception among the students, especially your senior batches, that there is a lot of mathematics involved in thermal science and engineering, which is why if you see the numbers, and I'm sure your seniors will also tell you that the number of students who take thermal science and engineering is quite low. Now, I don't know exactly when in history this transition happened. I say transition because earlier, when I was a student, I was also a dual degree student. The number of students who took thermal science and engineering was higher. Okay, and it cannot be this reason that 10 years or 15 years ago, people were unduly interested in thermal science and engineering. It's not like that. So some sort of misconception or misinformation got propagated sometime in between, and which is why this kind of a strange, weird transition has taken place. And we know that juniors mostly listen to their seniors much more than listen to their professors. So maybe it's a futile effort for me to say this, but I'll still say it, that in both in manufacturing science and engineering as well as in the applied mechanics and design, you will have to deal with quite a bit of mathematics also. In fact, in mechanical systems design, because that's where I'm from, there are a number of subjects which are mandatory subjects in your dual degree course, which involves heavy use of mathematics. So it happens sometimes like this, that people don't take thermal science and engineering, they take mechanical systems design to escape from too much of mathematics worries, but then they see that, okay, here also you have to deal with so much mathematics. So if you have even a little bit of interest in the thermal and the fluid side, I would highly ask you to seriously taking up that specialization also. Okay, it seems a little bit weird for me being a mechanical system design professor to say these things, but please do consider seriously taking that subject and don't get swayed by this kind of a misinformation that may be propagated by some seniors. Okay, so on that note, I will stop speaking and I will open up the virtual floor for questions and answers.
But before that, if you allow, I wanted to add.
Please, Atul.
Yeah, so actually one thing I was saying to the entire class, that look, broadly adding on what Jeevan has said, that broadly speaking, now whatever career decision you take can be divided into 2 categories. Okay, the first category is you are running towards something, and the second category is you are running away from something. So all the decisions that you take when you are running towards something, that is a good career decision, and all the decisions that you take because you are running away from something, that is always going to be a bad career decision. So not only for the choice of your dual degree subjects, but in general, whenever you make a career decision, please try to run towards something rather than running away from something. Running towards something will always be the better decision. I think, yeah, that's what I wanted to say.
Thank you, Atul. I'm going to steal that line in the future while giving advice to people. So, all right, students, please ask your doubts or whatever questions you have.
Hello, sir. Hello. Hello. Am I audible? Hello.
Yes, Shrish, please tell.
Yeah. So I'm Srish Mahapatra. So I wanted to ask something. My interest is basically in a field like mech-based robotics. I mean, I like the subject of mechanical engineering, and I want the robotics that is originating from mechanical, such as the field of soft robotics, the field of acoustic robotics. These all interests me. Uh, these all are my interests. So, like, I so what I wanted to ask is, in these fields, basically everything is coordinated with each other. Like, this field has biomanufacturing into it. This field has microfluidics involved, where we do the drug delivery into in cancer therapies, and then we also have designing where the material of the robots are studied. I mean, the material of the soft robots which we use to model are studied. So all these are encoded with each other. So being a dual degree student, I would also like to ask which path should I go into in order to enter into this, which is the most suitable for from these three subdivisions. Just that we have these three subdivisions, which path should I take up in order to study that?
Thank you,
So yeah.
Shrish. Since I personally mentioned about robotics earlier, I'll take this question if the others don't mind. Uh, so it's like this. See, what you are saying, you are asking about soft robotics and any other kind of robotics and the applications of robotics in different areas. That is absolutely fine. Which is why, as you go higher and higher, these kinds of artificial barriers that we have set up for logistical purposes, mostly within the department, that will start to melt away. Okay, as you go for higher studies and into the proper research domain. However, before that, as a dual degree student or as a master student, it is expected that if a student is interested in a certain research area, you would have done certain basic courses. Okay, now those basic courses, as it so happens in our department, is mostly done in the manufacturing science and engineering specialization. Okay, it does not mean that maybe you see that some professor is working in the area of soft robotics in the department, and it so happens that he or she is not in manufacturing science and engineering. Now, solely based on that information, you should not take the specialization which that professor is from. Similarly, if you think that soft robotics has an application in biomedical applications and you see that Professor Suman Chakravarti has been working on biomedical applications, you should not be swayed by that thing to take thermal science and engineering, because you will not be able to take up any of the basic courses that you should be actually studying. Because when you go for higher studies, whether it is in the institute or another institute or even abroad, you will need to show that you have done the basic courses. And this is not just for the narrow field of robotics. You replace robotics by any other kind of topic, what I have just said applies equally well. Okay, so you will see a number of professors who are working in domains which have cross-disciplinary, even cross-departmental inputs. That should not sway your decision. I would say that as informed and aware students, you first take a look at the overall depth courses which are there starting from your 8th semester, and then according to your interest, you take such a thing. Again, I would like to highlight what Professor Atul Jain has said. If by that kind of a proactive approach, you aim your target towards something, I think that will be a good decision.
Yes, sir. Good. Thank you.
Also, perhaps the one more thing that we can add is that, let's say you go to a certain division just because you like a certain professor. Okay, there is no other reason. You think that you want to go to XYZ division because you want to work with ABC professor. It does not imply that you will get to work with that professor. I mean, there is always a risk that, okay, you say that I want to work on, I don't know, let's say you say I want to work on composite materials, so I will come to, or I want to work with Atul, so I will come to applied mechanics and design. It is so possible that when the supervisors are being allocated, you will not be allowed to work with him, or that professor says that, look, I'm already having n number of students, I don't want n+1 students. So choosing a specific field just because you want to work with a specific professor can be a high risk strategy. Therefore, it is much better to focus on the courses that are there, that you can anyways take. But whether you will always get to work on the topic that you want or with the professor you want, that is not always the case. In fact, it is a high risk strategy. So yeah, I think I agree with Jeevan that you should look at the subjects much rather than looking at a specific person.
And further adding to what Atul said, it reminded me of something. So we have a certain provision in our department that suppose you take a certain dual degree specialization according to the subjects and the electives, the dual degree electives list that I have suggested, and then you find out that you want to still do your dual degree project with a certain professor who is not in your specialization. There is a certain provision here that you can still work with him provided you take another supervisor from your specialization. So for perhaps you take manufacturing science and engineering, but then you still want to work on soft robotics, and then you find that soft robotics is there's another professor maybe from mechanical system design who is working on that, or maybe you still want to work with Professor Suman Chakravarti and suppose he has a vacancy. So you take manufacturing science and engineering, and then you approach a professor maybe from robotics and thing, and then request that maybe some kind of a collaborative project work can be done. Okay, I'm saying this because I am doing something currently with one of the students, such a similar thing with one of the 5th year students. Okay, so it is very much possible.
Thank you.
Good evening, sir. Am I audible?
Yes.
I'm Sohan, so I'm a 3rd year undergraduate and I'm pursuing dual degree. So I had this basic doubt, like since my 2nd year, I was more like inclined towards stuff related to AI and ML. So I wanted to ask, like, how can I incorporate my research experience from AI and ML into mechanical engineering? Like, what are the prospective opportunities that are present?
Okay, I'll just speak one or two sentences on this thing, and then I'll request the other professors to chime in also. So regarding AI and ML, in each of the 3 specializations, there are professors who are applying AI and ML to their own research domains. It is there in thermal science and engineering, it is there in mechanical systems design, it is there in manufacturing science and engineering. Okay, so again, going back to my previous suggestion, you'd first choose what you want to study, and then you see that there will be certain professors who are applying such things, and then maybe target your entire academic direction towards that. I think that will, resolve your problem. But I'd still request other professors to chime in with their inputs.
Yeah, this is Nilanjan here. I agree with Jivan. So nowadays AI and ML, I think you're talking about artificial intelligence and machine learning, right?
Yes, sir.
Okay. So
basically my like prior experience has been in computer vision and natural language processing, and like I have a couple of publications also. So like I mostly my direction of work is related to that only. So I would like to pursue something related to that. So
yeah, so AI and ML that can be applied to any field. So which division you would like to choose has nothing to do whether you can use or you cannot use AI or ML. Okay, so in simple terms, you first choose which application, or what would be your future directions, and whether in that particular direction you can apply AI and ML, AI and ML, and accordingly you just choose the division, choose the elective, and go for it.
So like from the previous semesters, like I was more interested towards subjects like dynamics, kinematics of machines, and solid mechanics. So like how can that be related to AI and ML? Like
So why can
mostly
that not
this
be
comes under
related?
the Mech Systems Design.
Yeah. So why can that not be related to? Why can you
Like
not
yes,
apply
it
AI
can be
and
related, but I don't exactly know what are the prospects that are currently there. So
Yeah, see, research prospects means wherever you need some sort of optimization, wherever you need some kind of intelligent decision making, I believe you would use AI or ML, right?
yes, sir.
So you can use it in dynamics and kinematics of machine in designing a machine tool. You can use it in designing a machining process. You can use it in designing a particular methodology, which can be a numerical methodology, which can be an experimental methodology. So all the three divisions are well equipped to utilize the full functionalities of AI and ML. So you just have to find out which one interests you more among the three divisions, or what applications interest you more. So from the applications, you choose accordingly the elective, and you just go ahead. The AI and ML will not stop you from anything. Okay.
Sure, sir. Thank you very much.
Hello, sir. Am I audible?
Yes, Shravik, you're audible.
Sir, currently I am a third year BTech student, and I was thinking of converting into dual degree. So while searching for dual degree specialization in ERP, it was showing that there was a specialization called mechanical system, dynamics and controls.
That was
Professor,
during our time when I was a student. It no longer exists.
oh,
I told you, na, ERP is. I told you about one bug. There are other bugs also. This is another one.
okay, sir.
Yeah, yeah.
So I was
That
also
exists in our time. That was ME4, but later on, that ME3 and ME4 were clubbed together. So all the subjects which, like many of the more important subjects which are taught under dynamics and control, have been put in ME3 now.
ME3 means you are saying about mechanical system design,
Yeah, yeah,
right?
yeah.
So if I take mechanical system design, I will be get the opportunity to study the subjects of dynamics and controls.
I will not give you the answer. You go and search on your own. But
Thank you,
yes,
sir.
it is there. It is there. Yeah.
Thank you, sir.
Do you have any other questions, perhaps?
Hello, sir. Am I audible?
Who is this?
Sir, Narendra.
Yes, Narendra.
I'm a third year undergraduate student. Sir, I have one doubt. Like, I did not want to go in research. So, what should I prefer?
Are you a dual degree student or a BTech student?
Dual degree student, sir.
तो अभी तो यहाँ पे आ गए हो. At least till your 5th year you have to do, because unlike BTech project, dual degree project is not optional. You have to do it.
Okay, sir.
Okay, but you don't have to feel so down. Okay, I have known many students who had claimed that they are not interested in research, but once they start doing it, they like it so much they end up doing PhD also. I'm not saying that it's going to happen to you necessarily, but I mean, don't be so biased against yourself.
Sir, I have interest in ML and AI, but in mechanical, I did not have any interest. So, what should I do?
See, when someone says na that I am interested in AI and ML, this is actually a wrong sentence. Okay, this is like saying in nowadays I am interested in breathing. Okay, or even better, like I am interested in eating. Eating what? So saying interested in AI and ML makes no sense unless you actually say interested in AI and ML as it applies to so and so things. Because if you say you are interested in AI and ML, you need to be really a theoretical computer scientist, which only a minute fraction of people in the entire campus are capable of doing. What you are actually interested in is the application of AI and ML by using many of the well-established codes and well-established frameworks which are already available. It is the same thing which maybe 20 years ago everyone used to say I am interested in CFD. No, you are not interested in CFD. You are interested in the application of CFD in various things. Interested in CFD means you are interested in developing the fundamental algorithms of CFD, which is basically a mathematician's job. Very few mechanical engineers can actually do that thing in the proper way. Similarly, an engineer saying that I am interested in, like a non-CS person saying I am interested in AI and ML basically translates to I am interested in AI and ML in such and such an activity. Find such an activity and then you see what you can do within the department. Okay, I am telling you the answer exists.
Sir, but in departmental subjects like mechanics of solids and like dynamics of machines and all, I did not perform well. So I lose my interest in these fields. So what should I do?
So when you start, so you are now in your 6th semester. Since you're a dual degree student, you necessarily have to take up a dual degree specialization. So as per our previous discussions, you see the kind of subjects that, that you think you can do a little bit better in, because you know yourself best. No matter how much you discuss with others and seniors, that will not give you a proper picture. You know what you are interested in somewhat, and you take your dual degree specialization accordingly. Okay, but I think since you are the faculty advisee of Professor Atul Jain and Professor Mahendra Reddy, I think you should actually sit down for 5 minutes with them and discuss this thing properly. They can actually see your performance card and maybe give you some pointers in the right direction.
Okay, sir.
All right.
Okay, sir. Thank you, sir.
Yeah.
Excuse me, sir. Am I audible?
Yes. Rishabh, right?
Yes, sir.
Yes.
Sir, actually, we heard 2 or 3 third year students saying that they were more attracted towards AI and ML and so and so. And sir, my scenario now is like the same thing, but because I only got exposure in that. We can only do that stuff at home right now, and I don't want to end up in third year I have only done this ML and coding stuff, and I don't have any idea in any of the mechanical fields at all. And sir, our labs were also in online mode, so I even can't say I like welding stuff. I like machining and those things. And so how we can get our means we can get exposure to these fields, and yeah, that was my question.
Because I have been taking all the questions, I'll take this one also, but I will also request other professors to chime in again. So Rishabh, see, the reason that you have pointed out is an absolutely genuine reason. Okay, to lose somewhat interest in the mechanical subjects because you are not able to touch anything. Forget touching, you're not able to see with your own eyes what is happening. The kind of so-called labs that you have been going through, you're not actually seeing it with your own eyes. So it's a rather unfortunate situation. However, it does not mean that within the department there are no subjects where even sitting at home you cannot develop a proper interest. For example, earlier Professor Mahendra Reddy had mentioned about CFD. About many other subjects, there is a similar kind of situation where even sitting at home without necessarily having to look at a machine live in front of you, that would happen certainly better. But in this situation, it is still possible to develop an interest. like that. Such kind of computational modeling things again happen in all the three specializations. Whether it is mechanical system design, thermal science and engineering, manufacturing science and engineering, such kind of modeling, theoretical kind of things happen, like which are more on the science side of the engineering. Okay, so it exists in this situation. Since you are feeling somewhat affinity towards those kinds of abstract theoretical things like AI and ML, why not try to channelize that energy in this direction also? But you have to have a little bit of an open mind. If you just think that no, I mean, I cannot see anything, I cannot see any of the mechanical things, so I will not be interested at all, that would be rather very unfortunate. And I will request all the other professors to please help me in pumping up the motivation of the students a little bit here.
Okay, so you were actually very polite in the sense that you described the interest of students in AI and ML in a very polite, dignified manner. I think it is just bhed it's just herd mentality. That okay, somebody said it is good, इसमें बहुत scope है, then everybody is doing that without really knowing what it is or what is actually going to happen. I refuse to believe that out of 260 students, 180 students are naturally interested in machine learning and artificial intelligence. These have just become buzzwords. People like it because herd mentality, and there is somehow this notion that this leads to good job. That is not true. I think as students of the premier institute of the country, at least we should be the last ones doing herd mentality or trying to play it safe because this field has more job openings, so let me play it safe and let me go to this. I think we should be the risk takers. We, being in the premier institute, no, we should be the leaders rather than just following a herd. So I would request the entire batch to rethink whether you really like machine learning, or is it just because of you have heard from somebody, it is herd mentality, buzzwords, and looks nice on your CV. So please reflect on that. I think it is very important. Perhaps I'm sure after 2 years, like if today out of 200, 180 students are offered, if 200 are offered, 180, 160 will take up jobs leading to data analysis or big data. And 2 years later, they will think, no, I don't enjoy that. So I hope that does not happen with you. Please rethink, okay? Just because others have told so and so mein bahut scope hai, it doesn't mean that that is cut out for you. So yeah, I think I want to say this.
Hello, sir.
Yes.
My name is Prakhar Singh.
Yes.
Professor Atul Jain has described in his class about BTP and NTP. I would like to ask more about it.
For BTP, we are planning a separate session that will be formally done by the three coordinators, myself, Professor Anandaroop, and Professor Aditya Bandyopadhyay. So that will happen soon. Okay, I think we'll discuss that in a separate venue when all 200 students are there, because it is complicated. I mean, unless you have a general question, I will be able to answer. But if it is something which is complicated, because the rules are a little bit complex, but okay, you can ask me if you have some specific question. I will try to answer, but there will be a specific session on this. Yes, Prakar, what is your question?
Sir, you are telling about BTP and NTP but before the class, but I was not able to join early. So
we will arrange a special, I mean, there will be a different session on it with the three BTP coordinators.
Okay, sir.
Sir, hello, sir. Am I audible?
Yes.
So, like, I have a long-term interest in increasing the efficiency of machines and engines and all the renewable energy and harnessing in them in a better way. So, like, what should I pursue? Like, will mechanical system designs will be a better option, or like thermal sciences?
From what I understand, from what you have said, I think thermal will be a better fit. Yes, Jivan, Mahindra.
Yeah, I agree.
Yeah, Dr. Atul, I agree. Yeah, so here actually I would like to add one point regarding altogether. So far we have heard that many students are asking, I have learned machine learning or AI, then which direction should I go? So in that case, actually, what I want to suggest you in a certain process industry, okay, if it is a 10 components included, at each component actually two shift engineers supposed to be sitting over there, and periodically they have to collect all the data. Okay, so if it is 24 hours running, then how many shift engineers are required? To serve them, how many other employees are required? Suppose you are expertised in your AI and machine learning, then you will be adopting all the sensors and all together you have connected. That is like digital technology. Okay, that itself is finding out the fault. If the flow is overflowing or otherwise mass flow rate is increased, that itself is adjusting or metering the valve. Okay, like that, whatever the manual operations are there, you have to include your machine learning as well as with sensor technology and along with the automation. That way you can reduce manpower. Manpower reducing is only the not our ultimate aim. We can improve the efficiency as well as we can avoid the fault. System is full through. Okay, so like that, your intelligence of whatever AI or otherwise machine learning can be adapted anywhere, irrespective of thermal or design or anything. Okay, so wherever you are going more towards automation and improving the system towards the sophisticated. Okay, so that is one thing I would like to add regarding that.
Sir, also like I have one more question. Like many of the seniors say that you must know Python, MATLAB, and all this to apply for projects under professors. But like I wanted to ask, can't we perform all these calculations manually on pen and paper or something like that, or learning these softwares help uh, like I can't I'm not able to frame it in a proper way, but
Yeah, so I am also one of the seniors who keep asking the students uh, to learn Python and MATLAB all the time. So I'll take this question. Okay, so in mechanical system design, two of the courses that I teach, that I have taught, I have extensively used symbolic Python. The reason is that it involves so much complicated algebra, not hard, okay, just complicated algebra, just long and tedious algebra, that there was not much intellectual return of investment just by doing all those plus and minus and simple differentiation repeatedly. If we could outsource that kind of tedious work to an automated system like symbolic Python, then why not? We could better use our time to actually understand the physical system, the mechanics of the system, to and try to address more interesting situations by the time that we save. So any day I would advocate for the use of this thing to make our life easy. And you go to any professional research environment, this is exactly what is happening. They use more professional softwares like Mathematica, but they do use it. Okay, so I did both my postdocs in applied mathematics departments, and without exception, all of them use these kinds of software, computational algebra systems. Okay, and I have no vested interest in lying to you. Okay, I don't get any money from Python. Nobody gets any money from Python. So it's a free and open source software. So there you go. Okay, I think it would be rather foolish in the third decade of the 21st century not to learn any of these things which are at your fingertips. Like it is so easily accessible to you. Okay, it will be really like zabardasti ka, I mean, constraining yourself to a disadvantageous position. Please do not uh, be under any sort of like biased mindset against the use of these things. Okay, it is absolutely necessary for you to keep your analytical abilities on pen and paper sharp, but that should not be for the sake of doing tedious algebra. Like where actual brain work is required, there you sit down with pen and paper, shut down your laptop and do the actual brain work. But where tedious algebra is involved, just outsource it to these kinds of things.
oh, okay, thank you, sir.
Please excuse me, sir. Am I audible?
Yes.
Sir, I am a second year undergraduate student in the mechanical engineering department. Enrolled in it.
What are you doing here, Ritam?
Huh?
What are you doing here, Ritam? This is for third year students, na?
No, sir. Actually, I was thinking for converting to dual degree specialization, but sir, I had some doubts, so I joined this session.
Okay.
Sir, actually, the thing is that after coming to IIT and taking up mechanical and studying it for about 4 semesters, sir, actually, when I was doing my JEE counseling, so I was getting a seat at IIT Kharagpur in mechanical department. So my parents said that okay, but sir, after coming here, after studying it, but sir, I realized that I don't have interest in mechanical engineering, and nor do I have any interest in all those data science, machine learning, Python, and all those things. So, sir, when I was in my +2 level, in my school, I did not have the subject called statistics. But where I used to go for mathematics tuitions, so there a teacher used to teach statistics, and I used to listen to it. But sir, I have a genuine interest for statistics. So, sir, could you please guide me that how can I divert my stream from mechanical to statistics?
Well, divert is too strong a word, but I can tell you that whether you do modeling kind of work, like you have to go for higher studies, okay? I mean, the kind of things that you are asking, I can only say that from the perspective of higher studies. Whether you go into any of these specializations kind of thing, you will see that there is heavy, like immense use of statistics, whether you go into a modeling kind of work, theoretical kind of work, or certainly for the experimental kind of work. Okay, I would even go as much to say, I know I'll receive flack from many people for saying this. I would just say, I would go as much to say that AI and ML are just like dressed up versions of statistics. Okay, so if you're really interested in statistics, you actually have a hidden superpower in you. Okay, by all means, I mean, keep that interest alive, do the subjects well in the mechanical engineering department as much as possible. And once the stage comes for you to get into research, get into the kind of project which will enable you to push forward in a direction where there will be heavy use of statistics. And trust me, there will be. Okay, and I'll request the other professors to please help me out also, because they have broader, together we can give you a broader perspective of these things.
So Ritam, I just want to know one thing. When you appeared for mechanical, so there was an option for mathematics, or you appeared because your parent want you to appear? I did not understand the story.
Sir, actually, my father wanted that you go for core engineering, because since he was also a student of mechanical engineering, so he said that go for mechanical, electrical, civil. And I was not in a position to get computer science or electronics in IIT. Did not have that rank. So accordingly, I prepared that list: instrumentation, and then electrical, and then mechanical, then civil, and after that chemical metallurgy. So I thought that I'm getting mechanical in a premium institute, so why not accept it?
So that means you relaxed your interest.
Yes, sir, actually.
If you have already relaxed your interest once, why do you regret?
Sir, but then I did not.
Okay, anyways, I don't want the whole story. So another possibility could be, I don't know whether it is still existing. There is something called QEDM. And in QEDM, I think it's a separate route or something, but somehow you can try to opt for industrial statistics in future. You can think about it. To get industrial statistics, you have to take the IEM route, but how IEM route works or whether it works here at all or not, I don't know. But you can certainly opt for industrial engineering, systems engineering electives to do some work in industrial statistics.
Sir, will doing a minor in some field work?
No clue. You have to talk to the academic section, or probably, I don't know, who's your faculty advisor?
Professor Probarundhan.
Okay, so speak to Purbarun, and probably he would suggest you something.
Okay.
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 Okay. Any other questions?
No, sir.
No, I'm asking others. Other students, any more questions?
If you don't have any questions, I will get back to the organizers of this thing, the Mekanika guys. So we're organized. So even this is virtually done. So Bhalchandra, do you want to say something? Because everything has been revolving around you.
No, sir, I don't want to say.
All right. So Kanha, so I'm handing the virtual mic back to you.
Yes, sir. So with this note, we can close the event. We are really thankful for all the professors to give us their time and provide all of us with the valuable insights. The recorded video of this session will be available on our YouTube channel, and the link will be circulated with all of our batchmates and juniors as well. Thank you, sir.
Yes, Kana, very nicely organized.